Hello, everyone. We are going to start our 8.4 notes today. We're on 262 here in that student journal. We're going to go through 8.4 today. The nice thing about 8.4, we really just have the one day. I know that we're going through chapter 8 super quickly. I know that it's a lot, but really, we have today's lesson. We're going to take our quiz early next week. You're going to have one more lesson. We're going to add 8.5, and then we're just going to test on all of chapter 8. All right, so I know we're going through really quickly. We just wanted to cut this down to the absolute bare bones. Okay, so 8.4 is all about vertex form. I know it says even and odd function. We're going to skip that because I don't really care about it. Vertex form of these quadratic functions, it's basically another way to write the equation. So you're not really going to decide whether you're graphing in standard form or vertex form. You're going to be given equations. You have to decide whether that function is in standard form or vertex form. And then you're going to have to graph based on what method you can use to find your vertex. Okay, so let me explain a little bit more. You've got the old graphing that we just did. That was when we had an equation or a function in what we call standard form. That is that ax squared plus bx plus c. We had to do my vertex, I've got to find my x value is negative b over 2a, you'd plug it in. That's how we'd find the vertex in standard form. That's what we're used to. That's what we just did earlier this week. With vertex form, okay, where we have this x minus h all squared plus k. So let me show you an example of what this might look like with numbers, because sometimes it's easier to see. So 2x minus 5 squared plus 4. Okay, when we have this format instead of the standard form, the nice thing is we don't have to do this negative b over 2a stuff to find your vertex. When it's in vertex form, you can look right at your function and you can already just tell, oh, my vertex is going to be what we call h and k. Okay, your vertex, and I'll write this down, is at h, k. Meaning, this number that's right here inside the parentheses with your x, that is going to be the opposite of that number, okay? Because this is where it gets a little tricky. It's x minus h. It's saying x minus 5. That means that in this example, my vertex, that x value would just be plain 5. It's saying x minus h. So if I have x minus 5, my vertex is just 5. All right, if I had, let's say I had x plus 4. Okay, that would be the same thing as saying x minus a negative 4. That vertex would start at negative 4. So really what you just need to remember, this number in here with your x is the x of your vertex. You've got to swap the sign on that number. For k, since we see this is just plus k, this sign does not change. That's really the way that people mess up vertex form, is they forget which number should change and which should stay the same. The x we need to change. I'm going to give myself some more room. We need to change our sign. For k, for our y, that's just going to be 4 for my vertex. We're going to have the same sign. And that's really it as far as finding your vertex. When you're asked to find the vertex, if it's already in vertex form, it should be really quick. Okay? You really don't have to do any math. As long as you know the rule, you're good to go on your vertex. Then the method of graphing is really the same as what we did before. We want to find the vertex, which is now much quicker if we have it in this form, and we're still going to plug in different values. We're going to put those values on the graph. Okay, so let's go through in a little bit more detail. We're skipping this even odd stuff. it gives you two different sections. Okay, one is just for x minus h. We can just think of this as it's still in regular vertex form, just with a plus 0 at the end. If you don't have a plus k, you know that your vertex is just going to be, let's say this is y is equal to 3x minus 2 squared. I know my vertex is going to be, okay, change my sign with my x, it's just 2. My y, I didn't have one, so I know it's plus 0. That's all there is to it. To me, this is the exact same method that we're using when we have a plus k. Your book likes to separate it into two for some reason, but to me, it's exactly this method. We just have a 0 for our k. So I'm going to go over here. Okay, this is kind of what I've explained already. Our vertex form. So again, you're not deciding whether you're graphing in vertex or standard. You're going to look at the equation that you're given and decide, is this a standard form or is this vertex form? Okay, really the key, the clue, if you have this x minus 3, x minus 2, x plus 4, all in parentheses together, that's a vertex form equation. All right? Because in your quiz on your test, I might not say, oh, this is vertex, this is standard. You might have to identify it yourself. Okay? It talks about all these transformations, but really the important thing again, let's say I had y is equal to 2, x minus 3 all squared plus 1. When I ask find the vertex for this equation, you're looking here and swapping your sign. So instead of negative 3, you're going to say 3. And here's your y. You don't change that sign. 3, 1. Okay, if it was this graph, my vertex would be here at 3, 1. Right? So finding our vertex should be somewhat simple. Okay, we're skipping the even odd. If I asked you on one of these to find the vertex, we'd think, okay, this number in here with my x is my x. I just got to switch the sign from negative to positive. I don't have a k. There's no plus something, so I know it's plus 0. I know that vertex is 2, 0. Okay, over here, same thing. This 8 in here with the x, I know that's my x. It just has to change sign. So negative 8. There's no k, so I know it's just plus 0. So negative 8, 0. Let's move on to something with k values. Here we go. And these numbers on the outside, these a values, when you're finding your vertex, you really don't care. You don't care if they're negative or positive. You don't care. It really doesn't affect where your vertex is. You're just looking inside the parentheses. Okay, that's my x. I just have to change sign. So negative 1 to positive 1. That's going to be my y. Don't change the sign. It's just 4. Okay, once you do this a couple times, it's really the same process every time. Okay, I want to find my vertex. I need my x and my y. My x is in here with the parentheses. Okay, from positive 1 change to negative 1. This stays the same sign. It's still negative 5. All right. So let's get to graphing one of these. I want to do number 10. I think most of the ones in the homework are more like 10 than 9 because I think all of them have k values. I don't think any of them are like number 9. Again, if I gave you one of these to graph, just think plus 0. My vertex here would be negative 2, 0. All right, but I'm going to graph this, and I'm actually going to go over here to another tab where I have a bit more space to do my math and to graph it out. So I'm going to write that over there. All right, so I have our equation here. Sometimes we get thrown off when it says g of x, f of x, m of x, q of x. all of it doesn't matter if it's F, G, whatever, it's all the same. I'm just going to put Y because it's exactly the same thing, right? It's really the same process that we would do for standard form, where the first thing I want to do is, okay, where is my vertex? The nice thing here is that it's really easy to find the vertex. I don't have to do that negative b over 2a stuff anymore. I can just say, oh, my vertex, well, this is in vertex form. I see it's not in ax squared plus bx plus c. I see it's in this vertex form with the parentheses. So I'm going to change the sign of my x. So from -6, it's going to go to +6. My y is going to stay the same. My vertex is at 6, 4. Okay, I can come up with my little chart, x and y chart. Same as before. I don't want 6 to be my first number or my last number. I want 6 to be the middle number because I want 2 points on either side. Again, it's nice because I don't have to do the math for my y value of my vertex. On standard form, I would have to plug in the x, do all this math, find, oh, okay, it's 4. Here, I already know what it is, so I'm going to put the 4 in my table as well. Okay, so I want 2 lower than 6, 2 higher than 6, so I'm going to go 5, 4, and then 7, and 8. So really, I only have to plug in 4 and 5. It works exactly the same where whatever number I use for 5 is going to be the same for 7. Okay, they're both 1 away from my vertex. Whatever I use for 4, I can use for 8. They're both 2 away from my vertex. So we're only having to plug in 2 different numbers. Okay, so let's go ahead. It looks a little ugly at first, and that's okay. -1/4, I'm going to plug in 4 first, so 4 minus 6 squared plus 4. Right? So 1/4, 4 minus 6 is going to be -2 squared plus 4. -2 squared, that's going to go to +4. -2 times -2 is going to give me a +4. So 1/4 times a +4. Still have my +4. I can think of this. I've got a little fraction, multiplication that I can do here. So -1 times 4 is -4. 4 times 1, it's going to be +4. So I know that's going to be just -1. Okay, so -1 here plus 4, I get 3. Right, so that's my number for 4. I'm going to find 5 now. Right? This one, I may end up with a decimal. And sometimes you're not always going to get nice square whole numbers, and that's okay. I would say for graphing, normally I'd tell you, keep it as a fraction, but when we're graphing, I really don't mind if you have these numbers as decimals. It might be easier to try and figure out where, 3 and 3.5 is versus like 7/2. So 3.5 is probably easier to find on your graph. So as we're going, if we need to change something to a decimal, that works too. Okay, so let's look over here at 5, because I don't think 5 is going to come out as nice and easy as 4. Okay, -1/4. I've got 5 minus 6 now. Oh, it is going to come out nice and easy, but my point still stands. If it does give you a goofy number, just change it to a decimal. Right, plus 4. Okay, -1/4. Okay, 5 minus 6. It is going to be a whole number, so -1 squared plus 4. Okay, I know that's just going to end up with +1 when I square that -1. Okay, so -1/4 plus 4. I guess I do have to worry about a decimal or fraction here. If it makes more sense to you to say, okay, well, 4 is really 16/4. So -1 plus 16, so I have 15/4. You could do that. I think that'd be hard to think about where on the graph 15/4 would be. So you could either decide, okay, well, that's going to be 3 3/4, or you could just say, you know what, -1/4 is -0.25 plus 4. It's a 3. -0.25 plus 4, and that's going to get me 3.75. Whatever makes more sense to you, you're just coming up with values to throw in your table. So however your brain works, that's fine with me. I'm going to put the 3 3/4. Okay, I'm going to be careful as I repeat values. Sometimes people want to put like this value right here. They would want to say, okay, this is 3 3/4. But remember, the reason this works is we've got that axis of symmetry. So I know that 1 away from my vertex on both sides is going to give me the same y value. So I'm going to get 3 3/4 here for 7, and I'm going to get 3 for 8. Right? So let me come up here with a little graph. I'm going to come up with my x and my y axis. Okay, so there's my y. I'm going to draw my x way down low because I don't have any negative values here. I know these aren't perfect. I'm drawing them on my laptop, so you can cut me a little slack. I've got over here, oh, my x values are really large too. So actually, I'm going to change where I draw my y value. I'm going to draw my y, or my y-axis way over here, so I have plenty of room. All right, so I have 4, 3. So 1, 2, 3, 4, and 1, 2, 3. Then, okay, I have 5, which is at 3 3/4. So if you're ever in between two numbers, just kind of guesstimate, right? It should be a little bit more than half, but again, I'm never going to be super picky about exactly where it goes. As long as it's in between the right two values, if you put it in between 2 and 3, that's not right. Okay, so just be careful. But it doesn't have to be exactly right. 6 gives me 4. Then I've got the same on the other two. So 7, that's at 3 3/4. 8 is at 3. So I have a nice wide U. Okay, I'm going to connect my dots here. It's easier to make this one not pointy. Okay, and then just continue out. I'm never going to mark off if you have different angles here. Just as long as you connect your dots and then you just continue on that U shape on either side with your arrows, that's fine with me. All right. Make sure you have some graph paper. Get that 8.4 assignment done. Hopefully you got a practice quiz in class. I know some people are out, so I'll make sure to post that digitally on Schoology as well, so you can start on that. Remember, we're taking that quiz either Monday or Tuesday of next week. And then we're going to do 8.5, and we'll be done with chapter 8. All right, I'll see you guys soon.